Hello everyone, welcome back to my YouTube channel Trouble Free. In today's video, I am going to explain you about 0 by 1 knapsack problem with FIFO branch and bound in the subject of design and analysis of algorithms. So in the previous video, we already saw what is 0 by 1 knapsack problem with least cost branch and bound. I suggest you to watch that video first and then come here because I have explained everything in detail over there. So I'm just going to continue the explanation by thinking that you already know what is upper bound, lower bound and everything. So yeah, let's get into the video. First, it is same as least cost branch and bound, but the only small difference it has is it has global upper bound. I'll tell you what do you mean by global upper bound and what is the use of that global upper bound. So let's try to understand this with an example. For example, n is equal to 4. N is equal to 4 means you have 4 elements, and m is equal to 15 means the capacity of knapsack is 15. Okay, and then so what are the profits of 4 elements you are having? It's 10, 10, 12 and 18, and coming to weights it's 2, 4, 6, 9, the same problem as of the previous example. Okay, and what is the first step? You have to convert all the profits into negative profits, right? So you're just keeping negative symbol in front of all the profits, minus 10, minus 10, minus 12 and minus 18. So this is the first step that you have to do. Okay, now you have to start with node 1. For node 1, you have to calculate upper bound and lower bound. Okay, so let's first start with, I'm drawing tree here in this paper. Okay, so let's first start with node 1. Okay, for node 1, let's calculate the upper bound and let's calculate the lower bound and upper bound as well. So you know how to calculate the lower bound and upper bound, right? For lower bound you can accept the fractions, for upper bound no fractions. So for node 1, lower bound, first you have to take 2. After taking 2, what is the remaining capacity? 13. In 13 you can fill 4. Yeah, so what is the remaining capacity? 9. In 9 you can fill 6. So what is the remaining capacity? 3. Since in lower bound you can take fractions, you will take this 9. So what is remaining? 3, right? So you will get it as 3 by 9. So take the profits, minus 12 and minus 18. So what will be the total lower bound here? Minus 10, minus 10, minus 12, minus 18 into 3 over 9, which will be equal to minus 38. So in this case, the lower bound of node 1 is minus 38. Now let's do the upper bound. So for upper bound, fractions are not allowed, right? So fractions are not allowed means only these 3 things will come. So 2, 4, 6, minus 10, minus 10, minus 12. So you will get the upper bound of node 1 as minus 32. Okay, so the lower bound is minus 38 and the upper bound is minus 32. I told you here global upper bound, right? Global upper bound is nothing but the upper bound of the first node. Okay, so the upper bound of the first node will become, so this is minus 38 and this is minus 32, and the global upper bound is also equal to minus 32. As of now it is minus 32. Next time, for any node, if you get the upper bound value which is less than this, then you have to update. Otherwise you need not update. You have to get something which is less than minus 32. Okay, then only you can update this global upper bound. Till then you can maintain the same global upper bound. Got it? So this is the main thing that you have to remember. Okay, and from node 1 we have 2 nodes again, node 2 and node 3. So this is x1 is equal to 1 and this is x1 is equal to 0. You already know this from the previous video, right? So this is x1 is equal to 1, x1 is equal to 0. Now let's calculate upper bound and lower bounds for node 2 and node 3. Node 2 is x1 is equal to 1, node 3 is x1 is equal to 0. So for node 2, I think we have to break this video also into 2 parts because I don't know, but let's try to not break it again. Yeah, let's see. So what will be the lower bound? Node 2 means what is the condition? X1 is equal to 1. X1 is equal to 1 means what? First element pakka. First element is fixed inside the knapsack. From the second element onwards, if you are still having space, then you can keep it. Otherwise, you have to leave the other elements. So here you are keeping 2. After keeping 2, you are having more place, then only you kept 4, 6 and 3 or 9, right? So this is the same scenario of this thing, right? So if you want me to explain, I'll explain you again, but this is the same scenario. That is, x1 is equal to 1 means first element is pakka, first element is 2. So 2 pakka. So after 2, 4, 6 and remaining is 3 by 9. So minus 10, minus 10, minus 12, minus 18, which is nothing but the similar scenario, right? You're getting the same situation as this one. Both are same situations. So here what will be the lower bound? Same, minus 38 only. So upper bound also you will get the same situation again. So what will be the upper bound of node 2? Minus 32. Okay. Now let's do for node 3. Node 3 means what? X1 is equal to 0. X1 is equal to 0 means what is our question? 2, 4, 6, 9, right? That means you should not take the first element. Instead of first element, you have to take the other elements. Let's see. So first you are taking 4. After taking 4, how much is remaining? What is the total capacity of the knapsack? It is 15. How much is remaining? 11. After that, 6. How much more is remaining? 5. So you get 5 over 9. So what is the lower bound now? The associated profits also, minus 10, minus 12, minus 18, right? So what will be the lower bound? So you will get minus 10 and minus 10 here, minus 10, minus 12 and minus 10. So you will get minus 32 as the lower bound. Okay, and what will be the upper bound here? Upper bound means no fractions, simple. So 4 you take, then 11 more is remaining, and then you keep 6, and then 5 more is remaining. You cannot fit 5 because you have 9 over here, so you can leave it over here. So what are the associated profits? Minus 10 and minus 12. So upper bound of node 3 will be minus 22, minus 10 plus minus 12. Okay, let's update the values over here in the tree. So node 2 is similar to node 1, right? So lower bound of 2 is equal to minus 38, upper bound of 2 is equal to minus 32, and lower bound of 3 is equal to how much? Minus 32, and upper bound of 3 is equal to minus 22. So in both the cases, the upper bound is greater than or equal to the global upper bound, right? So if the upper bound is greater than or equal to global upper bound, then same. If the upper bound is less than the global upper bound, then you have to update. Okay, minus 32 is equal to minus 32, so keep the global upper bound same, and then minus 22 is greater than minus 32. Guys, it is minus. If it is just 32 and just 22, just positives, then 32 is greater, but since it is minus, here minus 22 is only greater. So since the upper bound value whichever you got is greater than the global upper bound, you can keep it the same. Okay, so you're going to keep it the same. The global upper bound is not changing. Now what you have to do is you have to compare the lower bounds. Okay, so now our condition is, if the upper bound is less than the lower bound of each and their respective nodes, then you should not expand those nodes. If the upper bound is greater than or equal to the lower bounds of the respective nodes, then you have to expand it. Now check. Here the lower bound is minus 38. Minus 38 is less than minus 32, right? So you can expand this node. Minus 22 is also not minus 22. You have to compare the lower bounds, right? So minus 32 is equal to the global upper bound. So in both the cases you can expand them, because minus 38 is less than minus 32 and minus 32 is equal to minus 32. So you can happily expand both the nodes. Okay, so first let's expand this 2. So if you expand 2, you will get 4, 5, because 3 is already finished here. 4, 5, and then if you expand this, you get 6, and then you get 7. Okay, now what you have to do is calculate the upper bound, lower bound, upper bound, lower bound for all these 4 nodes. Now what is the condition here? Here it is x2 is equal to 1, x2 is equal to 0, and here also x2 is equal to 1 and x2 is equal to 0. Okay, now let's find out the lower bound and upper bound for node 4. Coming to node 4, what is the condition for node 4? Look here. How we are coming to node 4? Node 1 to node 2 and node 2 to node 4, right? So x1 is equal to 1 and x2 is equal to 1 is the condition for node 4. So x1 is equal to 1 and x2 is equal to 1. What do you mean by this? x1 is for sure and x2 is for sure. Then if there is more space, then you can accommodate x3 and x4. So lower bound means again same. You are fixing 2, you are fixing 4, and then after this, how much more space is remaining? 13, and here 9, and you are accommodating 6, and after 6 how much more is remaining? 3. So it will be 3 by 9. Okay, so you can write the profits also, minus 10, minus 10, minus 12, and minus 18. So you will be getting the total value as, I'm writing it directly guys, so you'll be getting it as minus 38 again, lower bound of 4, and upper bound of 4 is nothing but again same situation as the previous one, to be frank. So you'll get 2, 4, 6. This fraction part you will not get it. So what will be the upper bound now? The upper bound would be minus 10, minus 10, minus 12. How much? Minus 32. So upper bound of 4 is minus 32. Now let's go for node 5. So for node 5, what is the condition? See, x1 is equal to 1 and x2 is equal to 0. Okay, how you are coming to node 5? x1 is equal to 1, x2 is equal to 0. So x1 is equal to 1, x2 is equal to 0. That means x1 is for sure. This is your question. x1 is for sure, no x2, x3 and x4. So let's calculate the lower bound. So how you will get the lower bound for this? x1, 2, no x2, so you can leave 4, next 6. So after 6 how much more is remaining? 13 minus 6 is 7, so 7 by 9. Okay, and here it is minus 10, minus 12 and minus 18. So what you will be getting, the lower bound of node 5 as, you will get it as minus 36. If you calculate it, you will get minus 36 guys. If there is any wrong, let me know. Actually no, minus 22 and then 14, yeah, the same, yeah, it's minus 36. Okay, so lower bound is minus 36. Now calculate the upper bound. Upper bound means only these two things, right, without the fraction. So 2 and 6, minus 10, minus 12. That is upper bound of node 5 is minus 22. Okay, let's update the values here. So for node 4 we got minus 38 and minus 32, right? So for node 4 lower bound is minus 38 and upper bound is how much? Minus 32. And for node 5 we got minus 36 and minus 22. So lower bound of 5 is minus 36, upper bound of 5 is minus 22. Okay, now let's do for 6 and 7 also. For node 6. Node 6, what is the condition first of all? How you are coming to node 6? x1 is equal to 0 and x2 is equal to 1, right? x1 is equal to 0 and x2 is equal to 1. So x1 is equal to 0 and x2 is equal to 1. So let's see how do we fit it. x1 is equal to 0 means no first element. You can take the second element. Third and fourth element, if there is space, you are fixing them. So let's do that. First you are fixing 4. So after 4, 11 is remaining, and in 11 you are fixing 6, So 5 more is remaining, then you will have 5 over 9. So it is minus 10, minus 12 and minus 18 are the weights. Okay, so what will be the lower bound of node 6 now? Minus 10, minus 12, minus 18 into 5 by 9. That is, you will get it as minus 32. Okay, now coming to upper bound. Upper bound means only these two without the fractions, because in upper bound fractions are not allowed. So 4 and 6, minus 10, minus 12, which is equal to minus 22. So upper bound of 6 is how much? Minus 22. Now let's do for node 7. So for node 7, let's see what is the condition. So this is our tree. How you are coming to node 7? 1, 2, 3 and 3 to 7. What is the condition here? x1 is equal to 0 and x2 is equal to 0. Okay, that means no x1 and no x2 also. You are not taking 2, you are not taking 4. You are going with only 6 and 9. Okay, let's see. So yeah, if you fix 6, how much is remaining? 9. So 9 exactly you can fit. Okay, and what are the weights associated? Minus 12 and minus 18. So what is the lower bound of node 7? It's minus 30, right? Now upper bound. Upper bound means same without fractions. Since we don't have any fractions here, you will get the same for upper bound also, right? So it is minus 12, minus 18. So upper bound of 7 is also equal to how much? Minus 30. Okay, now let's fill the values to our tree. For node 6, lower bound is minus 32 and upper bound is minus 22, right? So for node 6, lower bound is minus 32 and upper bound is minus 22. For node 7, lower bound and upper bound, how much? Both of them are equal to 30. So for node 7, minus 30 and minus 30. Now let's see. First check for, you have completed all the root nodes, right? Yeah. Now check for global upper bound, whether you have to update global upper bound in any of the case or not. When you have to update, if the upper bound whichever you got is less than the global upper bound, then you have to update, right? Check for all the root nodes. Here it is minus 32. Minus 32 equal to minus 32. Here it is minus 22. Minus 22 is greater than minus 32. So no. Minus 22 again. It is greater than minus 32. No need to update. Minus 30. This is also greater than minus 32. So you need not update the global upper bound in any of the cases. You can keep the global upper bound the same. Now check with this condition. If the global upper bound is less than the lower bound, then you cannot expand that, right? So in all the scenarios, in which case that is happening, where the global upper bound is less than the lower bound, here minus 38 and minus 32. So this is satisfying, right? Minus 32 is greater than or equal to minus 38. True. Minus 32 is greater than or equal to minus 36. True. Minus 32 is equal to minus 32. True. But minus 30, it is greater than the minus 32. That is, the lower bound, that is the upper bound, is less than the lower bound. So upper bound is less than lower bound means what? You will not expand it. You will not expand the node. You can kill that node over there. Okay, don't get confused, guys. The global upper bound should be lesser value. Here it is less, right? Minus 32 is less than minus 30. Okay, don't get confused, guys. I confused a lot because it is having negatives. So that is why I'm telling you, don't get confused with the negative values. Okay, so you can kill this node at this point. So you need not expand this node further. Okay, so now let us expand node 4. So if you expand node 4, you will get after 7, you will get 8 and then you will get 9. Okay, and so let's do 8 and 9 first and then let's go for the 5 and 6 nodes. Okay, what is the condition here? x3 is equal to 1 and x3 is equal to 0, right? Now let us calculate the lower bound and upper bound for both node 8 and node 9. So for node 8, what is the scenario? Let's look at the tree. So it is x1 is equal to 1, then x2 is equal to 1, and then x3 is equal to 1. So all are 1s. So x1 is equal to 1, x2 is equal to 1, x3 is equal to 1. Okay, now let's calculate lower bound and upper bound. Guys, I'm stopping this video at this point, and from this continuation I'll explain in the part 2, because the video is becoming very lengthy and it will become difficult for me to upload, and it will become difficult for you guys also. Like you will get bored by looking at the long video. So I'm stopping it here. Let's continue in the next part.